Okay, this is going to be my first video on section 7.2, and we're going to talk about how to use a calculator to find the area of a normal distribution, seeing as we don't want to use calculus. So let's suppose x is some continuous random variable. I don't care what x is, I know it's continuous because it's normally distributed. But let's narrow it down a little bit, because what you do need to know about a normal distribution is you need to know what the mean is and you need to know what the standard deviation is. So these are somewhat randomly selected. I have a mean of 50 and a standard deviation of 7, and I would normally have units, except I don't know what x stands for. Let's use this information to find the probability that I get an x value that's somewhere between 40 and 65. Okay, now I cannot encourage you enough to draw the normal distribution. And let me put in a nice clean copy. So here's a nice pretty normal distribution here, so you're not stuck with my sloppy drawings here. And the mean here is going to equal 50. And if I go out one standard deviation, I'll be up at 57, and then I'll be at 64, and then I'll be at 71. And if I went down standard deviations, I'll be at 43 here. And notice that between 36 and 64, that's most of the area. By the time I get down to, I think that says 29, then I have hardly any area left there. And so what I want to find here is the area between 40, which is roughly here, and 65. Just a little bit over 64. So this is what we're trying to find, and Mr. Calculator is gung-ho, ready to help us out. Now this is a distribution, and so in order to find the area of a distribution, we need the distribution button that is located if you press the shift key and then vars. And then this is really close to the top. This is actually going to be choice number 2, normal CDF. Okay, so this is what normal CDF looks like in your calculator. If you've got one of the newer calculators, it'll say normal CDF at the center of the screen, and then you'll have these choices here. It'll ask for lower, it'll ask for upper, it'll ask for the mean, it'll ask for the standard deviation. Now I'm hoping these are pretty straightforward. The mean is 50, the standard deviation is 7. What's the lower and the upper? What this means here is lower is the lower limit or the lower bound of x. We wanted the probability that x was between 40 and 65, so that's the lower limit. And the upper limit that x could be is going to be 65. And then we go down to the bottom of the calculator and we pressed paste. If you have an older calculator, then you're going to have to put in the following syntax. When you ask your calculator for normal CDF, it's going to open some parentheses and expect you to put some stuff in here. And what you're going to put in there is going to be the lower limit, then the upper limit, then the mean, then the standard deviation. So on an older calculator, just like the one I have, it's going to be normal CDF is going to be everything from 40 to 65, a mean of 50, a standard deviation of 7, and whether or not you have your calculator look like this or you have your calculator look like this, it is going to return at, oh man, this is going to equal 0.9074. So it is that straightforward, but of course, just like everything else this quarter, there's a couple of curveballs. What if, in fact, you wanted to compute the probability that x was less than 45? Well, again, I'd really love it if you drew that picture here. So here's the mean, here's 45, and here's the area you're trying to find. There's going to be a reason for drawing the picture. But for now, what we want is normal CDF. And what we want to put in is the lower limit, the upper limit, and the mean and the standard deviation. Well, no problem on the mean and the standard deviation. That's going to be 50 and that's going to be 7. The upper limit is 45. What the heck is the lower limit? Really, this goes all the way out to negative infinity, but you don't have a negative infinity button on your calculator. So what you're going to do is you're going to put in something ridiculously low. Okie doke. And if you do that, you are going to get 0.2389. And so lastly, what if you wanted to find the probability of x greater than or equal to 65, which I'm just going to stress because this is continuous, is exactly the same as the probability of x being strictly greater than 65. They're going to be the same, which is why it doesn't matter when I put this into the calculator whether or not I'm going to include the 65 or not. I don't have to communicate that to the calculator. So the probability that x is greater than 65, the lower limit this time around is 65. The upper limit has to be something ridiculously large. And then the mean is still 50, the standard deviation is still 7. So what we should get out of this is, this is going to equal, once we paste it, won't stop that, 0.0 0.183. Okay, so this time my random variable are your SAT scores. And so now I do know what x is. So we're going to apply this problem. So we're still talking about a mean of, well, now it's a mean of 1060 and a standard deviation of 195. This first question, what's the probability that a randomly selected person got a score that was between 100 and 1,000? And do I include the 800 or the 1,000? Your choice. It doesn't matter to me. So we're talking about a normal distribution, the center of which is at 1,060, and we're talking about the values that are between 800 and 1,000. And how do we find that area? We go for normal CDF, and we say, could you find all the probability of having a value between 800 and 1,000 if the mean is 1,060 and the standard deviation is 195, please. And you know what? I don't think I have the answer to this. Hang on a second. Let me look it up. Hey, I'm back. And according to my calculator, if I put this into my calculator, I'm going to get that we're going to get 0.2879. Okay, well, while we're at it, let's find the probability that this person scored below 1,000. So that's what this guy looks like. I still have the mean here at 1060. 1,000 is just a little bit below that, and I want to know what this area looks like. And I'm drawing the picture to help me figure out what's my lower bound This would be negative infinity, except I don't have a button for it. What's my upper bound? And so we're going to put into our calculator normal CDF. And question, are you finding that okay? It's on the dist button, which is right above the vars button. So normal CDF, and what we're going to put into there is something ridiculously low. Something way lower than an SAT score could possibly be, on up to 1,000, with a mean of 1060 and a standard deviation of 195. And I did look this up, and I'm getting for this 0.3792. Hope I didn't make a mistake. Okay, so let's clear the screen here and let us do that last problem. Okay, so what's the probability that a randomly selected person scored over 1,400? So let's get the correct tool here. The mean is, oh, my bell curves are getting much better. And here's 1,400. And I'm trying to find the area of this tail here. So back to normal CDF, where's that? Dist button. And then it's your second choice, normal CDF, and my lower bound is 1,400, and it's going up from there. 1,400 is the first value you put in. Upper bound is going to be ridiculously large. You can't just stop at 1,600 because your calculator doesn't know that we're talking about SAT scores. It doesn't know that's the maximum value. So you're going to have to go much larger than that. Maybe I'll even throw in an extra 9 there. And then we'll put in the mean. I'm running out of room here, so I'll put in the standard deviation a little bit below. I press paste, and what I get is 0.0406. Okie dokie, so that's how you find probabilities on a normal distribution.